Okay, in this lesson, we are going to be learning about the binomial theorem, and this is probably brand new to you, and it gives you a little bit of a shortcut on ways that you can expand some really long things, okay? So I'm just going to remind you, first of all, this is the very first problem where I'm asking you to expand a plus b squared. That doesn't mean, like a common mistake people make, that you square the a and square the b, like distribute that through. That's not what you do. Remember that to square something means that you multiply it by itself. So you have to take a times b, or a plus b times a plus b. So if you FOIL this, you'll have a squared plus ab plus b squared, which of course can be simplified as a squared plus 2ab plus b squared. What we're going to be paying attention to in the binomial theorem is a couple of different things. First of all, we're going to be looking at the coefficients. So the coefficients of this are 1, 2, and 1. The other thing I want you to notice is this. The the powers of a go down. This is a squared, a to the 1, and then back here I don't even have an a, so I have an a to the 0. The powers of b go up. I don't have a b here, so this is b to the 0, this is b to the 1, this is b squared, okay? That's a pattern that happens that we will look at in our binomial theorem here, okay? This is excuse me, a little bit confusing, but it gives us written out if we have expanded a plus b to the 1, a plus b squared, a plus b third, a plus b to the 4th. And again, what I want you, first of all, in this particular example, to pay attention to is what's happening to the a's. So right here, this is a to the 0, by the way. It's also b to the 0. Okay, in the next line, I want you to notice how I have b to the 0, then b to the 1. Here, b to the 0, b to the 1, b to the 2. So the b's are going up, while the a's are going down. A squared, a to the 1, a to the 0. That pattern continues all the way through. My a's are going down while my b's are going up. So a to the 5th, then a to the 4th, then a to the 3rd, then a to the 2nd, okay? While my b's are going up, b to the 0, b to the 1, b to the 2, okay? Then you have these coefficients that are out in front, and there is a pattern to these also, which I will kind of point out to you in a minute, but I want you to look at the variables first, and then we'll go to our coefficients here in a minute. This is some really fancy notation that shows you how to get the coefficients each time, and I'm going to explain this not in this notation. Okay, so this is telling us to expand a plus b to the 4th using this handy dandy little rule right here. Okay, here's what this means. All this means is this. Okay, you're going to start your first row by doing 0, C0, and that will always be 1, okay? In your next row, which is, this is like row 0, okay? In your next row, which is like row 1, okay? This is what you're going to do. Since it's a row 1, you're going to start by choosing 0 objects first, and you can literally type that into your calculator and do 1C0, and I'll tell you you get 1. And then you're going to do 1C1, okay? When you type 1C1 into your calculator, you're also going to get 1. Row 2. That means you start with 2 objects. You're going to first choose 0, and you get a 1. Then if you have 2 objects, you're going to choose 1, and you get a 2. Then if you have 2 objects, you're going to choose 2 of them, and you get a 1 again. Okay, row 3. 3 objects. Start by choosing 0, and you get a 1. And then choose 1, and choose 2, and choose all 3. Okay, when that happens, you'll get 1, 3, 3, 1. Okay, and then you go all the way to row 4 because that's the last number back here. And you'll start with row 4. I should do this so that this isn't so confusing. When you get to row 4, You'll go 4C0, 4C1, 4C2, 4C3, 4C4. You're going to get answers for each single one of those into your calculator, and it comes out to be 1, 4, 6, 4, 1. Okay, now we could continue that pattern all the way down the row. I want you to just see some patterns, hopefully, that you can see. First of all, and this is supposed to be more in a diagonal, hopefully you realize that this diagonal is all 1. Okay, this diagonal, the numbers are increasing as you go down, and same thing if I go the other way. Then what I want you to notice is I want you, excuse me, to notice this. If I add 1 and 2, I get 3. If I add 1 and 2, I get 3. If I add 1 and 3, I get 4. If I add 3 and 3, I get 6. Okay? And you can kind of see what's going to happen the whole entire way down. So I could complete the next row if I needed to. I know it's going to start with a 1. I know this is going to be a 5. Then I can add 4 and 6 gives me 10. 6 and 4 gives me 10. 4 and 1 gives me 5. And then, of course, it has to end in a 1. Okay? And I can complete that row after row after row after row after row if I wanted. That gives me some coefficients that help us expand things in a short way. Okay? And so we're now, and that's all called Pascal's triangle, by the way. Okay? What we're going to do is we are going to expand now a plus b to the 4. Well, actually, I did that. Sorry. We're moving on. Okay, what the binomial theorem does then is it combines those two things, the coefficient piece that I just got done showing you, and how the exponents increase for the a and decrease for the b. Okay, so I will kind of expand this so that we can see this. Okay. So here's what this next thing is asking us to do. And I'll kind of do this so that you can see this, see how this happens, okay? What I want you to notice is that this is to the 15th power, okay? So that means I need to have 15 rows. I need to be at the 15th row. So and remember, it starts at row 0. I need to be at the 15th row. And I need to figure out what would happen for a to the 9th, okay? This is how that would look like, just so that you can see this in expanded form. The 15th row, the very last row in that triangle thing, and I don't need to do all the rows ahead of it, but the very last row in that triangle would look like this. The coefficient would be 15, 0, and then it would start out with a to the 15th, b to the 0. And you don't write the b to the 0, but that's how it would start out. The reason it starts out at a to the 15th is because that exponent is there. Okay? Then the next term, I'm just going to put a plus in here, would be 15C1, and it would go a to the 14th because my a's go down, and b to the 1. Okay? My next term would be 15C2, and it would go a to the 13th, b squared. A's go down, b's go up. The next one, I think you can see a pattern here, 15C3, a to the 12th, b to the 3rd. Okay, I'm just going to keep going. The next one, I'm going to go down here just because I'm out of space. The next one would go 15C4, a to the 11th, b to the 4th. Okay, the next one, 15C5, a to the 10th, b to the 5th. The next one, 15C6, a to the 9th, b to the 6th. Okay, this is the term it wants. It wants me to find the coefficient for the a to the 9th term. That's this term right here. The coefficient of that will be this part of it right here, which is 15C6. That's the coefficient, okay? So I will stick that into my calculator, do 15C6, and then I get 5,005. Okay? We will do the next one now. This is asking me to expand it, and I'm going to expand it with I know you know how to expand this the long way and just multiply x plus 1 times x plus 1, but this is what I'm going to show you. I'm going to do this with smaller numbers here so that you can see this. I'm going to say, like, this is my A, and this is my B, okay? So my A is x, and my B is 1. And I'm basically going to use my rules that I just did before. Notice my exponent is 2. So when I get to my last row, I have two objects. I'm going to start with 0. I will have a squared b to the 0. Okay? The power on the a is always the same as the power that's up here. Okay? Then I'll go 2c1, a to the 1, b to the 1. Then we'll go 2c2, a to the 0, b to the, 2. Okay? Then you need to know numbers for this. So I punch in 2c0 on my calculator. That's 1. Okay? A is x, so that's x squared. B to the 0 is 1. Anything to the 0 power is 1. I don't need it. Okay? 2c1 is a 2. A to the 1 is the same as x to the 1. B to the 1 is the same as 1 to the 1. Okay, so 1 to the 1 is just 1, and I don't need it. 2c squared is a 1. A to the 0, anything to the 0 power is 1, and I don't need it. B squared is like taking 1 squared, and 1 squared is 1. So 1 times 1 is 1, and I am done. Okay, and I know that that seems a little bit longer, but that's how you're going to do it, even if you have longer terms to think about. Okay, so we're going to do a couple more of these so that we can practice. Okay, the next one says find the coefficient of x to the 10th in the expansion of this term right here. Okay, so here we go. The expansion of x to the 10th. I'm going to say that this is my A and this is my B. Okay, so here we go. Again, power of 15. So I will start off with 15C0, A to the 15th, B to the 0. 15C1, A to the 14th, B to the 1. 15C2, A to the 13th, B squared. 15C3, A to the 12th, B to the 3rd. 15C4, sorry, A to the 13th, sorry, yeah, A to the 13th. What am I doing here? 12, not 13th, A to the 11th, sorry, I'm going to start this one over. This should be 15C4, A to the 11th, B to the 4th, and then 15C5, A to the 10th, B to the 5th, okay? All it's asking me is for my coefficient of the x to the 10th term. A is the same as x in this case, so basically this is the term I'm talking about, and 15C5 will give me my coefficient, okay? And 15C5 is 3003. All right, and the last one, we are actually going to expand or the next couple actually, we're going to expand all the way, okay? So here we go. This is to the 4th power, so luckily we don't have so far to go, but here's the deal. This is your A, and this is your B. Okay, so we're going to expand this. I want you to know this is to the 4th power. Here's how it goes. I have 4 objects, so I will go 4C0 times A to the 4th, B to the 0. 4C1 times A to the 3rd, B to the 1. 4C2 times A squared, B squared. 4C3 times A to the 3rd, B. And then lastly, 4C4 times A to the 4th, B to the 0. Okay, now you need to have some numbers and some things to plug into this. Okay, we'll start out with our coefficients. So the coefficient to 4C0 is 81. No, it's not. It's 1. Sorry. What am I doing? This is 1. Okay. The coefficient to 4C1 is 4. The coefficient to 4C2, and you can kind of look at these triangles, or the Pascal's triangle, or the little triangle things back in your notes and figure that out. That's a 6. 4C3 is a 4. And 4C4 is a 1. Okay, so those are the coefficients. Now I need to take a to the 4th power. Well, a is 3x, so I need to take 3x to the 4th power. B to the 0 is 1, so I don't need it. Okay? Then I need to take a to the 3rd power. A is 3x to the 3rd power, and b is 1, so I need to go 1 to the 1st power. Okay? I'm going to put plus signs in between here. Clearly, this got a little bit crooked. Sorry. A squared would be 3x squared. And then b squared is 1 squared. Okay? Plus sign in between. A cubed, or yeah, 3x. It should not be 8. Oh my goodness, you guys. I screwed up. This is not right. I screwed up right down here. Okay, maybe you guys caught that before. This should be a to the 1, b to the 3rd. This should be a to the 0, b to the 4th. Okay, sorry about that. Good thing I caught it. All right, so this is 4 times 3x, and then, so that's my a, okay? B to the 3rd is 1 to the 3rd power. Okay, and then lastly, a to the 0 I don't need, that's just 1. B to the 4th would be 1 to the 4th power, okay? Now you have to simplify this. So what I have here, I need to do my exponents first. So 3x to the 4th would be 81x to the 4th, which I will then multiply by 1, which still gives me 81x to the 4th. Okay, this becomes 4 times 27x to the 3rd times 1, which when I do that becomes 108x to the 3rd power. Okay, this becomes 6 times 9x squared times 1, which becomes 54x squared. This becomes 4 times 3x times 1, which of course becomes 12x. And then this 1 to the 4th power is just simply 1 times 1 is still 1. Okay? So that's how we would expand that whole thing. All right, and we're going to do one more of those. Oh my goodness. And I think we can handle this. All right, here we go. This one's just a little more complicated because it has a negative sign in it. Okay, so here my a is 2x, my b is negative y squared. Okay, notice there's a minus sign in here, so your b has to be negative. So here we go. Again, it's to the 4th power, so I will start out at 4c0, a to the 4th, b to the 0. 4c1, a to the 3rd b. 4c2, a squared, b squared. 4c3, a to the 1, b to the 3rd. 4c4, a to the 0, b to the 4th. Okay, so now I plug my things in. All right, so I'm going to try to do this a little more diplomatically here. 4c0 is 1. A is 2x, which I then have to take to the 4th power. Okay, b to the 0 I don't need because that's just 1. 4c1 is 4. A is 2x, which I have to cube. B is negative y squared. Okay, on to the next one. 4c2 is 6. A is 2x, which I have to square. B is negative y squared, which I have to square. 4c3 is 4. A is 2x. B is negative y squared, which I have to cube. 4c4 is 1. A to the 0, I don't need. Anything to the 0 power is 1. And then b to the 4th would be negative y squared to the 4th power. All right, this gets a little bit more complicated to simplify, but here we go. This becomes 1 times 2 to the 4th power is 16x to the 4th, which makes 16x to the 4th. Okay. This next one becomes 4 times 2 cubed is 8, x cubed is x cubed, times negative y squared. When you multiply that then, you have 4 times 8 times negative y, which becomes negative 32, x cubed, y squared. On the next one, we have 6 times 4x squared. Okay, then in the next one, when you square this negative that's right here, squaring a negative will make it positive. So it's going to be positive y to the 4th. And then when you multiply that out, you have 24x squared y to the 4th. Over here, we have 4 times 2x. Then when you take this negative and cube it, a negative times a negative times a negative is still a negative. Y to the multiply the exponents and you get 6. So when you multiply 4 times 2 times that negative in front of the y, you do get negative 8x y to the 6th power. And then over here, when you take this negative to an even power, a negative times a negative times a negative times a negative is going to be a positive, and then y to the 8th. Okay, so that's how you would do all of those expansions in the binomial theorem. And that's that lesson.